Good morning.
Good morning. Uh,
All turn in your assignments.
Good morning, Professor.
yes, we turned in.
Okay, let me check it. Okay, only four. Only four is there. Esther, Gloria, Andy, and Eileen. Please turn in the assignment first, okay?
Okay.
We still have 3 students haven't shown it up yet. Moody, Andy, and Linda. Okay, I think we need to start to have our class. Especially today is for the presentation of our third class activity. Okay, so as usual, we will start it from those PhD students, then the masters. All right. So why, Gloria? Why don't you start it first? Okay.
Okay.
Would you share your screen and just show your assignments and do the presentation according to your own assignments, okay?
Okay. So I will now to share my assignment.
Yeah. Share
And
screen first.
okay.
Share screen first, okay?
Okay.
All
So
right?
can you
Yes.
see it?
Yeah. Sure. Okay.
All right. Okay. There. Here is my assignment, and for the exercise 7, it is a question A is test for serial correlation at the 5% level in this equation. My answer is with the Dubin-West test, because if D is smaller than 1.643, then we can reject null hypothesis. So since D is equal to 0.5, so it is less than critical lower limit of the statistic. So we will suggest to reject the null hypothesis. So as a B question B.
Excuse me.
Excuse
me. How did you get these critical values? Durbin-Watson test. How did you get it?
I find it on I think I find it online.
I mean, checking with
there is a trouble, so I find it online because checking that it is only, I think it's 100 or something in the appendix.
Oh, you mean according to the table of our textbook?
But it's not. So I'll check it online.
Oh, really?
I think. Yeah.
Okay. That's okay.
Okay. So question B, what metric problem appear to exist in this equation? So I think if they have a serial correlation problems, so maybe we will suggest GLS or UniWest to, yeah. Right. And then the C, I think the question C, when the dummy variable di, the percentage will get at 7. So it says that we think at the result at 9, if you feed the pig, that will put on the more weight. So maybe it is good, better to feed them at night. So for D, the transmission and order from youngest pig to oldest, does this information change any of your answer to in this ordering mistake? I think this order is not because the order of observation of time series is fixed. So you have to keep the observation in the time as long as the time period is fixed, and so the order is not much different. So I think the order of the youngest pig to the oldest does not influence to the equation. Yeah. So as for the lab 5, the step 1, I have put this with the e-views. That's my results. So accordingly like this.
Okay.
And step 2, the estimate aggregate consumption function. So my answer is like this. I put different I put TPI as the Y, so this is the result. And the second, I put AAA as Y.
Excuse me.
Yes.
Gloria, excuse me.
Yeah.
Can you would you please make the printer larger?
Larger? I think larger,
Yeah.
or like this.
Enlarge the percentage. Yeah, that's right.
Yeah, like this?
Yeah,
Better.
yeah, okay.
Like this. Okay. Yeah. And then, okay.
All right.
So yeah, these are results. So for the step 3, so we have to examine the residuals, and actually the question requests that generate a residual from the regression step 2. So put them as a line graph against year. So put a year on the X-rays. That's what I said before. I don't know how to do it. So I
Okay.
stuck here.
All right. All right.
Yes. And then step 4, I have to run the Adobe Western test, and the answer is like this for me. Then this hypothesis I have found, and yes, and I check the DL and DU is from the back, is the appendix. So we reject the null hypothesis because of no positive serial correlation now. So I will run, later on, I run the Lagrange multiplier serial correlation test. And yes, this is after I do the Lagrange multiplier test. So null hypothesis is like this. So it's after that you can reject the null hypothesis and conclude that we have serial correlation in the model. And this is my result. Okay, it is step 6. They will estimate the model with generalized least squares. So my answer is I use generalized least square. So after that, I will come find out this result. So they said as are the GLS coefficients and T statistics the same as OL's coefficient at the test. So I compare this with the previous one. So it is almost the same for this part coefficient. They're almost the same. So this, and as a question C, I think is what is asked before. Okay, anyway. So my answer is after GL's transformation. Because after I did this, the Dubin-Watts test is different because here it becomes 0.95 something. Is much smaller, so there shows no serial correlation. So it is remedies the serial correlation. And at step 7, if at step 7, I have run the GLS model in step 6. So I estimate the aggregation consumption model. Use the new West method at the leg of 1. So this is my answer. So and the coefficient the same as OL's coefficient. So the standard error is different. And for C, why are newlyweds t-test statistic different from the OL's t-statistic? My answer is true. The serial correlation caused no bias in the estimate of the hats. So the GLS estimates usually different from the OL's ones. So it turns out that GLS work well. Row hat is close to the actual row. So, but the GLS row hat is based in small samples. So if row hat is biased, then the bias row hat introduce bias into the GLS estimate of beta hat. So the newlyweds t statistic different from the OLS t statistic is because the model does not have time positive serial correlation. So above all, thank you.
Okay.
Thank you.
Okay, then let's see. Is Andy there?
Yes, brother, I'm coming. I'm here.
Okay. Would you present your assignments?
Yeah, okay, but we have to sharing or not?
So are you just in?
Yeah,
You're
I
not
just
ready
in.
yet?
I ready,
Huh?
bro. I'm looking for the what? This one.
Have you turned in your oh yes, you did. You did turn in the assignment. You all turn in assignment? Let me
Yes,
check it.
Yeah, I said already in assignment.
All right. And so Andy, are you able
Yes.
to share your screen?
Yeah, okay, bro. Thank you. Can someone share my screen? Hold on.
Yeah, share your screen first.
Yeah.
Okay.
Already?
Yeah, okay. Yeah, I see the screen.
Okay, okay.
Okay, would you please make it larger
Yes.
or make it a full screen too?
This one?
Oh, yeah, yeah.
Not so big, bro. Okay.
Oh, that's too big.
Yeah.
That's too big. I think it's about 130% will be okay.
One.
This is too big. Yeah.
This one?
Yeah, okay. Nice.
Okay, I'm try.
So yeah, so
Good. Yeah.
start with exercise 9.7.
Okay. Good morning, Professor. Good morning, my classmate. Today I'm going to present my assessment. Before that, honestly, I'm so difficult to make it and don't understand, and then I'm trying my best. I'm going to the question A. The question is the test posterior correlation at the 5% level in the question. My answer the hypothesis if D under the L is mean reject hypothesis null. If D more than the U do not reject hypothesis null. If low under DW under D under upper inclusive. My answer, this one, we have to answer because this is not explained what kind the DW positive or negative. We going to two sides. In positive autocorrelation, we got the D 0.50 under 1.7 is mean reject hypothesis null, and then the 0.50 more than 1.7 same reject hypothesis null, and then the 1.74 under D 0.50 under 1.7 inclusive is mean we cannot account. And then for the negative autocorrelation, I just know the formula for minus dw equal 4 minus 0.50 is mean 3.5. And then the result 3.5 under 1.7 is mean do not reject hypothesis null. And then 3.5 more than 1.7 same do not reject hypothesis null. And then for the 1.7 under 3.5 under 0.788 is mean we cannot account is mean
Andy.
inconclusive. Yes.
Excuse me, Andy.
Yes. Yes.
Do you work with a Durbin-Watson test?
Yes.
Huh?
This one double Watson.
Did you work with Watson Durbin-Watson test for serial correlations?
Yeah, what I know is this one for double question. We just know about the low and upper prop.
But by Durbin-Watson test, we usually do one-sided test.
Yeah, it's right because one side is mean we're talking about the positive autocorrelation.
Yeah.
Yeah.
And also, by the way, where did you get the critical value?
This one? Which one, bro?
Where did you get that lower critical value and upper critical value?
By table, bro. Table wasn't that by table that wasn't for 5%.
Oh, you mean by table?
Yes, bro. By table, I
And
got
what
from
degrees
table.
of freedom are you using?
Yes.
What degrees of freedom are you using? How many degrees of freedom are you using for these numbers? Huh?
3, bro. 3. This one.
I mean the sample size.
The sample first to 100 and then the key variable is 3. It means 200 minus 3 minus 1.
You know, according to the table
Yes.
from our textbook,
Yes, Prof.
The sample size is really stopped at 100, but now we have 200, right?
Yes, 200.
So we are not able to get those critical values from our textbook, but you can just, just use the closed numbers. That will be okay. So my question is, how did you get that 1.74833?
This one I
Where
got
did you
from
get that?
I got from the table. There wasn't 0.45%, Prof.
Okay, which is
With the N 200.
okay, Gloria.
Yes, Professor.
This is different from yours, right?
Yeah, it's quite different from mine. Yeah.
Yeah. Then where did you get that critical
I
values?
found it from internet, so I try to search the doping test table on the internet. So
Okay,
there's
so
get it.
so far I don't have that on hands, but these two numbers are different.
Yeah.
So
Maybe
I'm not sure.
I will search online, and so I will provide it later.
Yeah, sure. And
Okay.
it's seems to me that the number is a little bit weird.
Okay, I'll just find it now.
Okay, I'm not sure which one is more close. Okay.
Yeah, Prof.
Well,
Okay.
Andy.
Yes, sir.
Okay, please go on.
Okay.
So you're working with two-sided, right?
Yeah. Two-sided.
Why did you work with two-sided?
Where?
Why did you work with two-sided? Since Durbin-Watson test usually is working with one-sided.
I read in some book in the Google. It said for the double Watson can use one side only positive and two side use negative. And then for the question this one not mention what we going one side or two side. This why I make it two side positive and negative. But this why I put this one, Prof. Why? Why? Because I want to know which one the better, which one the right.
Okay.
Yeah.
All right. Go on.
Okay. And then the B, what economic problem appear to exist in the equation? This one, the coefficient beta G is mean, we have to explain or not? Is and dummy variable, and then BD dummy variable as well, and then F about the amount of good pound pig. The value we got 3.5, and then for D 7.0, and then for F we got minus 2.5, and then T table by T table statistic we got 1.645 45, and then the 5% degrees of freedom 200 minus 3 minus 1. Giri should honestly, Prof, I'm confused this one. We don't know the answer. We just try to answer. It means all the Gini should 1.0 more than 1 more than 0.05, and the T value 3.5 more than 1.65, and then D result 1.0 more than 0.05, and T value 7.0 more than 1.6, and then F result 0.10 more than 0.05, and T value minus 2.5 more than 1.5 is mean reject hypothesis. We have implicit correlation, therefore, we assume that the more food a pig eat, the bigger it is, meaning that it change growing a high rate or low, that's negative sign, this one, the negative sign. And for C, the goal of our experiment is to determine whether feeding at night represent a significant improvement over feeding during the day, we cannot conclude. The coefficient of D, this one, coefficient D, 7.0, is significant is the expected direction, but given the problem with the equation, we be hesitant to conclude answer yet. For D, the observation in order from the youngest peak to the oldest peak, does the information change of your answer to the previous part of the question? My opinion, all of us to realize that younger people will gain weight at higher rate than their older counterpart. If the data are ordered by age, positive result will be concluded at one end of the data set, while we'll be giving the appearance of serial correlation. And then the exercise rate 5,
Okay.
this one. What I know, Prof, we see the variable triple A, they got the expected sign minus, and then DP, we got the expression plus. It means variable A, the expected sign, it is mean not indirectly related or reciprocally related to be variable con. Character personal consumption. Then for variable DP, expected sign plus is mean related to con. And then for the step 2, we go for the DPA, the coefficient 0.9, 0.93, and then the probability 0.00. And then for triple A, we got minus 12.54. And then for the probability 0.0017. Based on the result, every 1% increase in the DP 0.03 will increase consumption by $0.03, while 1% increase in triple E will reduce consumption by 12.6%, and the probability of DPA and triple A under 0.05. For the step 3, we got the plot. This one here and in residual based on the result plot is random because the plot is irregular. It means irregular plot. And then step 4, using by Darwin-Watson, this is the hypothesis for Darwin-Watson. And then this one to now the positive correlation one side, and then the answer 0.05 under 15.0 15.3.3 0.05 under 15.232 is mean reject hypothesis null. 0.05 more than 16.5 or 1.8 reject hypothesis null. This is as well, Prof. I got from double Watson table. Step 4. Step 5. Run the Langlet multiple and serial correlation. Which one we got for the...
Andy,
Yes.
Andy, excuse me.
Yes.
Just stop here for a while.
Yes, okay, bro.
And okay, you are using okay, Durbin-Watson test again, right?
Yes.
Now for these examples, okay, we have the sample size is 62.
Yes, bro.
Okay.
Yes, bro.
Then we do have now according to the Durbin-Watson test, the critical value tables.
Yes, bro.
Okay, at back of our textbook.
Yes, bro.
Okay, we do have the sample size, which is 65. So, which is pretty close to the n equal to 62 in this example. All right.
Yeah.
Then, according to the textbook, K is equal to 2.
Yeah. Equal
And
is-
the lower and upper critical value is lower critical
115.
value is 1.54. And
Yeah.
the upper one is 1.66.
Yeah. Same.
So
Almost same.
which is really different from what you have it here.
Really?
You see what I mean?
I see, Prof. Maybe, yeah. Maybe
So
about
where
this
did you
one,
get these critical values from?
I got from the double Watson table, Prof.
Well,
With,
I
with,
think you have
with,
the same mistakes or same problems with the question number 7.
yeah.
Using the Durbin-Watson test, I think the critical value over there is not right.
Maybe I saw only the
You
table.
see what I mean?
I see. I know what you mean, Professor. But it is a
And
good, yeah.
what do you mean by 0.05? Is this your D value of this
What
regression?
what I
What's
I
the
was understanding.
0.05?
Yeah. What I was understanding 0.05 is mean this one, Prof. The 5%.
No,
Yeah.
that's wrong. We
Yeah.
need to compare our D statistic with the critical values. So what is your Durbin-Watson D statistic from this regression?
You mean for the step
Do you
4
want
or
me,
step?
let's look at the tables.
This one?
No, on the top.
This one?
Yeah, this one.
Yeah. Yeah, Prof.
No. Where is your Durbin-Watson statistic? Yeah, here.
Huh?
What's the number here?
0.385, Prof.
0.3857 something, right?
Yes, Prof.
This is just your D numbers. You need
Yes,
to
Prof.
use these D numbers to
Oh,
compare
yes,
with
Prof. Yeah.
the critical values instead of using 0.05.
Yeah, I'm wrong, Prof. Yeah, this is my mistake. Yeah.
See what I mean?
Yeah, I understand, Prof. We have to change or not, Prof? Thank you very much for your
Okay, go
correction,
on.
Prof.
Okay, go on.
Okay. And then for step 5, run the LMC calculation test. Let's see is our double Watson result can be conformed with the LM test. For LM test, we can see the probability square 0.0, and then for the probability, we see for DP 0.7, and then triple A 0.5. I think this one I don't understand, Prof. Are no alternative hypotheses for yes.
Excuse me.
Yes.
Okay.
Yeah.
You are
I mean,
using leg 2, right?
this one.
You're using
Yeah.
2 legs.
Yeah.
In fact, we're using 1 leg only.
Oh, I see. Okay, I'm wrong again. Okay, thank you, Prof.
Okay?
Okay, bro.
So there's a little bit difference
Yeah.
here. Use
Okay,
just
bro.
1 leg only.
Yeah, not 2.
Because
Okay,
we want to compare that with the Durbin-Watson. Durbin-Watson test is only use the first order only.
Okay, bro. Okay, bro. Thank you.
Okay?
Okay, bro. No need to.
All right, go on.
Step 6. Estimate the model with GLS. And then for GLS, we got this one, bro. For DP, for coefficient 0.9, 14864, and then the T statistic 167.1092, and the probability 0.00, And then for the triple E, for coefficient, we got minus 7.651005. For this statistic, we got minus 2.668895 and probability 0.00898. And then what the GLS coefficient and statistic the same as the all S coefficient. We compare this one. Almost only DP coefficient is got the almost same because DP for LS 0.93 and then for GLS we got 0.91. After GLS transformation, does the calculation still appear to exceed? This is, I think, wrong prop because we're running with the two sets. Based on the result calculation, for the chi-square 0.00 under 0.05, this means still have correlation problem. And in step 7, for step 7 running with the new waves, we got this one for DP coefficient 0.93 2022 and this is statistic 152 for 42549 and probability 0.00 and then for triple E coefficient I got minus 12.54196 and this statistic minus 3.419403 and probability 0.0011. And then we have to compare the same for oil as result and new ways, coefficient same, yeah, and probability almost same, and the statistic different. And then for the C, the textbook asked about the statistic for the triple A almost same, 3.29, this is 3.66. Based on the result for the statistic, no same. Thank you very much, Professor.
Okay. All right, but for the new West
Yes, well.
estimation, there's a little bit, there's some problems here.
Yeah.
Okay. Okay, let me let's continue our presentation. Okay, would you how Eileen? It's your turn now.
Okay, Professor, I'm gonna share my screen.
So Eileen, would you share your screen?
Yes, hold on, Professor. Can you see it?
Not yet. Use the screen, share screen.
Hold on, Professor. Sorry. Can you see it now?
Oh, yes, yes. Thank you. Yes.
Okay. So for
So
Exercise
Okay,
7.
start your presentation, okay?
Yes. Question 7. Test for serial correlation at the 5% level. So we see someone shared the website for the lower and upper limit. We reject the null hypothesis that there is no positive serial correlation. For B, what econometric problem? There is impure serial correlation. Therefore, we assume that the more that the pig is fed, the more the pig gains weight, but the chances of the pig growing is low. Based on the test, can we determine whether feeding at night represents a significant improvement over feeding during the day? Coefficient B significant in the expected direction, which is positive, but I think we cannot conclude yet if feeding at night represents a significant improvement. I'm not sure if it's correct, Professor. D, observations. Is this ordering a mistake? Younger pigs will gain weight at a higher rate as compared to the older pigs. If the data are ordered by age, positive residuals will be clustered at one end of the dataset, while negative ones will be clustered at the other end, giving the appearance of serial correlation. That's for question 7, Prof.
Okay.
For lab exercise 5, step 1. So this is what's already presented. Expected signs positive for DPI and then negative for AAE. Means that real disposable personal income is related to consumption positively, and then real interest rate is negative. It is not unidirectionally related to real personal consumption.
Stop here, okay? What do you
That's
mean by the expected sign for AAA is negative, which means it is not unidirectionally related to CON, consumption. What does that mean?
Not similar that if it's positive, it will also be positive. So it goes in the opposite direction. Is it the correct interpretation?
Not unidirectionally related to consumption.
Yes. Or should I
Since it
not
is
use this?
negative, since it is negative, so means it's the opposite relationship. So what does that mean? Not unidirectionally.
I used the wrong term. It should be the opposite direction.
I think it's just negative relationship,
Just
right?
negative. Okay, negative. Okay.
And it really makes sense that when the interest rates is going up, then the consumption is going down because it's more expensive, right?
Yes.
Okay, go on.
Step 2, estimate the aggregate consumption function. So this is the equation.
Yeah, okay.
So the independent variable of DPI has a coefficient value of 0.932022 with a probability value of 0.0, therefore has a positive and significant effect on cons. For every unit increase in DPI would result to increase in cons by 0.932 or 93%. The independent variable of AAA has a coefficient value of -12 with a probability value of 0.0017, which is less than 0.05, and therefore has a negative and significant effect on cons. For every unit increase in DPI would result to decrease in cons by 12.54 or 1,254%. Step 3, examine the residuals and plot as a line graph. It's not the same as what Miss Gloria did. It's not a line graph, so I'm not sure if it's correct. The plot looks random because the results are scattered.
Actually, if we see these residual plots, it seems that it started, since this is 0, right? So this part is 0, and it's go up, gradually going to the positive side, then up to the highest point, then gradually go to the negative side, then up to the bottom of the negative side, then go up again. So this is really a pattern of positive serial correlations. I mean, the diagram shows the positive serial correlations. Okay?
Okay, thank you.
Okay, continue. Step 4.
Step 4, the Durbin-Watson test. I had the same lower and upper with Mr. Andy, so I think we have to correct this also because we use the same table.
Lower the critical value is wrong.
Yes, we will correct it, Professor. Step 5, run the LM test to confirm with the DW results. And for here, the null and alternative hypotheses are the same, but in the LM test, the probabilities of the independent variables DPI and AAE are greater, and for the DW test, the probabilities are less than 0.05. You mentioned a while ago we have to use one lag variable, but we use two lags here. So I think we also have to correct this, Professor. On which test could be used? Probably the LM test could be more appropriate than the DW test. LM test, the chi-square is less than 0.0.5, therefore we reject the null hypothesis. For step 6, estimate the model with GLS. And we estimate aggregate consumption using GLS. So there's the table. Are the coefficients and p-statistics the same? They are almost the same as for both for OLS and GLS. The serial correlation still appear to exist using the LM test. There still seems to have serial correlation because of the chi-square. I'm not sure if it's correct to look at the chi-square, Professor. And step 7, new West standard errors. So if you run the GRS, estimate the consumption using the NW method with a lag of 1. The coefficients of OLS and unit West are the same because I'm not sure if this is the correct answer, Professor, because they both test correlation and heteroscedasticity. That's why they are the same. Why are the T statistics different? Because the standard assumptions of regression do not apply. We could preferably use the NW because the T statistic is lower, showing more similarity. That's all. Thank you.
Okay. All right. Let's just stop here for a while. Then we will go to the second meeting. Okay. Okay, let me stop the recording first.